you're stuck with me today. I'm a Principal Applied Scientist in the Automated Reasoning Group, and I'm here to tell you about how to achieve the highest level of assurance with provable security. So our customers are often interested in how we do security in AWS. We have many ways that we secure the infrastructure, and we help customers secure their infrastructure. Things like classes and tutorials and tools and best practices. But I'm here to tell you about something new and something I'm very excited about, which is ensuring or helping to assure security using proof, using mathematical proof. So what do I mean by that? We're using mathematical logic to prove that the desired security properties hold of our systems. So we're not testing, we're not fuzzing, we're actually doing proofs in the sense of the kinds of math proofs that you used to do in class. So these are the foundation of truth, knowledge, and reasoning. And they've been pursued for thousands of years by people like Aristotle, Boole, Euclid, and Frege. And what we're trying to do here is we're making a finite argument about infinite structures. So what we're saying is, given something you can write down on a piece of paper, can we talk about all instances of something like a square or a triangle or a program? So let me give you an example. An example is the Pythagorean theorem written by this gentleman, Pythagoras, in 300 BC. And so what he proved is that the square of the hypotenuse, the side of a triangle, is equal to the sum of the squares of the adjacent and the opposite sides of the triangle. And he didn't fuzz it, he didn't test it, he didn't inspect it. What he did is he built a symbolic argument using constants A, B, and C that can stand in for any numbers. And in about the size of a page, he wrote down an argument that showed that it's possible for any triangle of any size to have this property. So what we're doing is essentially those same kind of proofs, but about different artifacts. Rather than talking about geometric figures, we're talking about programs or protocols. And doing this ourselves is really hard work. Pythagoras is remembered because the proof is hard. And so what we're trying to do these days is we're using computers to help us out. And so automated reasoning is really the use of algorithms to find and audit proofs in mathematical logic. So what we're doing is we're using these computers to construct a proof to talk about future behavior of computer systems. We want to be able to know the behavior without running them. So what they might do, what they will always do, and what they will never do. So we might want to know, for example, what they might do, that there is some way we can get into a bad state where we can't recover. We might want to know that they always do something, that they're always secure, and what they never do, that they never let an attacker in a particular way. So where is this used? Well, it's used a lot in hardware. So for example, floating point units are now checked against the floating point standard by virtue of proof. My background is in avionics, and so things like primary flight displays for aircraft and flight guidance systems, critical pieces of aircraft functionality, can be proved against their specifications. Medical devices, things like infusion pumps, can be shown to be correct with their specifications. And now this technology is moving into the cloud, and we're finding all kinds of places where we can apply it. So what we're doing is we're proving properties of programs, of protocols that communicate between services, of networks, and of policies. And when we do a proof, we consider all possible executions of the system. We have those same symbolic constants that you saw in Pythagoras' proof, but they have to do with the inputs to the program, for example. We also consider all possible requests or all possible configurations, in the same way that you could consider all possible right-angled triangles. So let me illustrate this using policies. So in IAM, we have a service that enables you to manage access to all of your AWS services and resources securely. So we can think about customers having all kinds of different capabilities in their accounts. Things like S3, where you can store data, or API Gateway, where you can provide an interface for users to call the service. And the question is, did I grant the permissions that I intended? You write these security policies that are designed to restrict who has access to some of the resources. So you can think about this in terms of having an account, say XYZ, that has several resources in it. And we can think of other accounts wanting access to some of those resources. So maybe the audit account should see your S3 bucket because it needs to be able to audit the data that's stored there. Or your website account needs to go through API Gateway, which provides an interface for customers to be able to call website capabilities. But then maybe you have another account, ABC, that has access to your KMS keys. And this is something you really don't want. So what we have is a tool called Access Analyzer. And what that allows you to do is see who outside of the owning account has access to resources inside the account. So what other accounts have access to those resources? And it'll present those in terms of findings, so you can look at those and make sure that they're what you expect. And we can do this not only at the account level, but also at the organization level. And how this works is there's an underlying engine that can answer yes/no questions. And so what we do is we encode the policies from IAM, things like the identity policy, the role trust policy, and the S3 bucket policy. And then we also encode the question that we want to ask. So for example, you could ask the question, is my bucket accessible outside of VPC ABC? And the tool, the engine, will say either yes or no. And if yes, it'll actually give you back a witness. It'll give you back a test case that shows how your bucket is accessible outside of this VPC. And the way that it does this is it codes both the policy and the question into logic. And then it uses an automated prover to tell you whether or not the property is true. And we use this to make things secure by default. We're using this in S3 to, for example, prevent public access to buckets that customers don't wish. If we wanted to do this by hand, we could never do it. There's so many buckets. It would take so long to inspect all of those policies. And so we leverage our tool, Zelkova, to do a comprehensive analysis. So this allows us, if you check this box, what it's going to do is it's going to run Zelkova in the background, and it is going to, with logic, prove that your policy does not allow public access. And we're using this not just here, but all across the development lifecycle. So we can use this in design and coding. We can use this in pre-launch security review. We have different capabilities, and we also can check systems running in production. So we're applying this automated reasoning early and often. And we're not just applying it to S3 or to IAM, we're applying it all over the cloud. And if you want to know more, please check out our website at Provable Security. aws.amazon.com/security/provable security. And with that, I'm going to hand things over to Matt.